My name is Philip Morrow. I've been with MLC CAD Systems just over 7 years, but I'm based in Austin, Texas, South Austin, where we have our main corporate office here. And this is where I went to college for mechanical engineering. It's where I spent some time in a CNC shop with SolidWorks. It's where I spent time doing defense contracting, using SolidWorks sheet metal and weldments, and a lot of simulation tools as well. And in the past years here at MLC, that's what I've specialized in, simulation tools, and recently some of the new 3D experience Dassault Systems products. But if you don't know MLC larger, that's my background. There's a whole team of guys with a similar background to myself here. You know, degreed engineers who use SolidWorks in the field, who came over to MLC and basically just went back to college for SolidWorks. And what we do is take all sorts of technical certifications, the public ones, but even more, to be able to be licensed and do different things and trainings and work with this software. So we're here to help you with all this stuff, from tech support to training to educational stuff like today. MLC's actually been doing this, you know, for 38, 39 years. That's every single release of SolidWorks and more. And I say and more because MLC's not just here to sell SolidWorks, not at all, or train and support it. The idea here is to make engineering companies more efficient, get stuff to market better, faster, and cheaper. And so that's a range of software, SolidWorks being one of them, but also services like custom and special projects, training, customizations and implementations of different softwares, like you might do with some of these high-end data management softwares, or the training that might go along with any of the different simulation products. So it's a pretty unique spot to be. It's why I've been here a while. It gives us a cool look at these different, you know, companies and how you guys are using tools. And we do a lot of research on what tools we feel are going to be the best for this type of job. So if you have questions really about any of this stuff in engineering workflow, reach out to us. That's what we're here for, is just to help you guys. Now today we're going to talk about some SolidWorks products that work together. And I think all of you guys here that I see in the list anyways, I know it's a lot of people that are seasoned SolidWorks users, and you're used to this, right? Not just, hey, I update a sketch and a part, and I don't need to update anything else. Of course, all that stuff is connected. If I update the part, my drawings, my assemblies, anywhere that part used is immediately up to date. That's how all SolidWorks products work, right? So if I get into simulation, if I get into technical documentation or even electrical schematics, everything should be connected. So I make a change in one place and it spreads everywhere else, right? And we're pretty used to this if you're a SolidWorks user. It also means you can do more things that you might have to wait for process A to get done. You can start them earlier. Even simulation tasks, you can do them in parallel so that basically all the operations just get done quicker, right? It's faster, it's more efficient, and it's connected. Well, the next step up from this is managing the data efficiently as well. Because you could do all this stuff and have all these connected data, but you could have multiple files around with the, you know, end naming on there, like final, complete, or someone's working on Rev B when they should be working on Rev C. So, you know, why don't we integrate this as well so that we have proper data management, you know, at the life cycle and revision control level, but just so everyone knows they're connecting to the right data at the right time. And there's actually more benefits to that when it comes to PDM. So I'm going to show some simulation today too, but I want to start with data management because it's such a big fundamental topic, and I feel like every SolidWorks user should feel the same way about data management that we feel about parametric connected data. It should just work seamlessly and never have a question of who's working on what at what time, who has access to what. So I want to start a little bit just talking about what is data management. Right, when you hear the acronyms PDM, PLM, ERP systems, we'll talk about what its fundamental things are to me as a CAD user, and then some of the key capabilities and benefits of SolidWorks PDM, and that's the name of the product I'm talking about today, SolidWorks PDM. And then I want to show you a live look at how it works while I make some engineering changes to things. I'll look over the questions at that point, maybe summarize what I've got over, and switch into simulation. I've definitely brought a lot today, so I'll try not to go over an hour here, but no guarantees on that. So let me start with what is PDM. And to me, the most core functional need of a PDM system is when I see files being shared across a network drive at a company. If you just have a network drive that you're putting everything on and people open from there, you've already probably ran into some read-write issues and some, you know, collaboration issues there. But what happens is when you take something off a network, that data gets broken down into packets. kind of like the Willy Wonka kid who got beamed into the TV and then it gets reassembled on the other side. Well, what happens if the power goes out while that kid's halfway in the air? Only his legs show up in the TV. That is data corruption. It doesn't matter what type of data you're working with. That's a common way to get data corruption. Your network speeds are going to go up and down throughout the day. So we want to be able to cache files locally and have versions stored on the network drive so we don't have such an openness to having some files suddenly go corrupt, and we've got backups and versions on either side. This also means, though, if you have a local cache, you're getting local performance. You have less bandwidth and things traveling across your network all day, so everyone's happy about the network speeds. But when you hit save, even though you're collaborating through a data management system, that file is stored locally on your computer, and you're getting local performance. That's a big deal. The thing that comes up is searching for files, right? If you have two SolidWorks files with the same name, if you've never checked out the file search order, it is fastest for your computer, not the most intuitive for your brain. It's going to go looking for a file by name, and it'll even just look in the last folders you were browsing in Windows Explorer. You could have been browsing to a network share drive, so you can find the wrong things. You don't have to worry about that with this data management system. It searches faster than a Windows search. It gets the right data at the right time. And then, of course, you get version control, rev control, so no one has to worry about ever losing work, overwriting the wrong work, or having duplicate files out there and getting the wrong one. These are all cured by SolidWorks PDM at the fundamental level. Now, I'm saying SolidWorks PDM a lot, so I think I should say there are a couple levels here that I'm also not talking about. One of them is 3D Experience SolidWorks. This is the new Dassault Systems cloud product that's been out just since July 4th. It's based on Innovia technology, and it's your plug and play. Access data from anywhere. It's in the cloud type of thing. Very easy to set up. What most people start off with is SolidWorks PDM Standard. This is included with SolidWorks Professional and Premium. This utilizes Microsoft SQL Server Express, which is free. Gives you all that fast database searching stuff, and this will manage any type of file. It doesn't need to be SolidWorks files. Anything you put in there will get managed. One level up from that comes SolidWorks PDM Professional. This is kind of the enterprise solution. If you have multiple sites, you want to replicate your server to other places, just want to work with a lot of people, this runs on the full Microsoft SQL Server and has just expanded capabilities from PDM Standard. You can always just flip a switch and get into PDM Pro. And at the very top level is actually a product called SolidWorks Manage. And this leverages PDM Professional. It sits on top of that to do project and process and item management. You can deal with Gantt charts and dashboards that show burn rates of projects and reports. It's pretty detailed. If you're into that type of thing, this high-level project management, definitely check out our YouTube channel. We've got a lot of stuff on there. So it's just youtube.com. Our user is MLC CAD Systems. Check out our Manage video Chris Souter put together. It's a great webinar. But I want to focus today on SolidWorks PDM Standard and SolidWorks PDM Professional, right? The stuff that I really feel like every SolidWorks user who's collaborating and all should set up. And there's just a few differences in between these two. I'll refer these at the end as well. But PDM Standard is essentially the same thing, but running on SQL Express, and it's a little bit limited in certain things here. You can see in tasks, it could output PDFs, or workflow states, it could only do 10. I'll get into what each one of these are. But this is the topic of the day. So when I say SolidWorks PDM, these are the products I'm talking about. This is a tool that controls, secures, and facilitates your daily work. And it allows departments like purchasing, manufacturing, guys on the floor who need a PDF print to access all this stuff just through the Windows Explorer tools they already know and make sure they're getting the latest PDF and they're getting the right stuff at the right time. This has integration into like Microsoft Office, even AutoCAD, Inventor, Solid Edge. It manages any file type at all, and you can just use Windows Explorer. So there's a few capabilities I want to go over before I get into a live showing of this thing. And there's a key takeaway in each one of these areas, starting off with your rate of return here, your fast ROI, or just your learning curve too. If you do give this out to different users who maybe are not even in SolidWorks, well, this is built in as an extension of Windows Explorer. So it looks exactly like a folder. If you're sharing on a network drive right now, it's going to look just like that, even though really there's all this local caching and database functionality. So it's just an extension of Windows Explorer, meaning people are going to know how to use it pretty much on day one. Now, what I really like about it is the search tools. If you've ever worked in Windows Explorer and just done a Windows search, it's not very effective. It's pretty slow, and it might take you to Bing. Well, because this is built on top of SQL, the searching is immediate. This is something I got to show you today. The searching is super powerful. You can parse data through all sorts of stuff. So, in Windows, I generally just browse for files. In PDM, I really take use of the powerful search capabilities. Now, a big reason to come to PDM is this revision control, and workflows are completely flexible here. So if we take even a PDF, what does it take? Who needs to sign off on it to approve it? Once it gets approved, does it go into approved folder? Do PDFs automatically get sent out to the shop floor? And we might have different workflows for how we want to approve different types of files. For instance, maybe you have an engineering change order process in your company. Certain people need to sign off. Certain people need to attach Word documents along the way. This is a completely flexible and configurable workflow to manage this type of approval process and revision flows. And as I mentioned, this is totally scalable. Whether you just start off with SolidWorks PDM Standard because it came with SolidWorks Professional and Premium, and you want to jump into PDM Professional down the road, it's just like flipping a switch. Or even if you go to PDM Pro and you have multiple sites across the world, you can do server replication over there, so nobody's ever waiting on data transfers. And of course, because there are these other systems, maybe you have a legacy PDM system, you have an ERP system, a CRM system out there, we can tie into these things, and that's part of the implementation and customization that comes with this stuff. So not only could we kick out the information and share it to others, with PDM, we can build hooks to pull in from existing systems and really help with that whole migration process too, if you just want to bring everything over into PDM from some legacy system. Of course, along the way, one of the great reasons that this is something you control and is locally installed is the granular security nature of it. At user levels, at the groups of users levels, even on folders, who can see what exists inside of them. So really, this is completely up to you. The control here could be met to any security guidelines. If you have ITAR restrictions, no problem. This is complete control system that you set up to the security level for any user that you need to. So these are just a few of the key capabilities I wanted to point out, the ones that come to the top of the list for me. I think it would probably help everybody here if we just take a live look at SolidWorks PDM and you can really see what's going on. So I'm going to switch over to SolidWorks. Here I've got an assembly open that I want to work with, and this is something that's inside of PDM. I just open it up like a regular SolidWorks file. Right now it opened up read-only, so when I open it, it's just letting me look at it and view it, but somebody else could be working on this thing for sure. And I want to make some changes here, so I'm going to open up a part. Let's take this gripper arm here. Now, I call it a gripper arm. What you're seeing here is essentially the jaws of life, but it's kind of a reverse jaws of life. This thing is used to spread parts around. Like if you have a car that's rolled over and you need to spread a space and open it up. And when I try to open a part out of it, it's actually warning me already, you're trying to make changes to a read-only document. It's even a document that I haven't yet saved in SolidWorks 2020, but it opened it up. Opened up read-only lets me look at it. To actually make this change and look around, I'm going to use PDM running inside of the SolidWorks task pane. This is called the PDM CAD editor, and it tells me what files I've got open, what version it's in, what state in the workflow. It's under editing workflow state, so you could make changes to this file. And all I need to do to take control of it is just choose checkout. When I check it out, it now says, hey, it's checked out by me. Philip's got it checked it out. It's no longer read-only, and other people are aware that I'm working on it now. Nobody else had it checked out, so it's just mine. So let's make a change. And I'm going to be fancy here. I'm going to use Instant 3D and just make a slick change here to make this a little bit thicker. That looks pretty nice. I think I'm okay with just that thickness. That's what I wanted to make. So if I check my task pane again over here, to share this with others, I really just need to check it back in. But before I do that, I'm going to do something that is just a PDM functionality. I'm going to check the where used information. Now, you might have seen this stuff before, like in file references. This is kind of the backwards of file references. If I'm modifying this arm, well, I'm going to be affecting this assembly and the drawing of that assembly. It doesn't look like there's a drawing of just the arm. So I know, okay, those are the other places I'm going to need to make some changes, I can handle that. And I'm going to go ahead and just check this thing back in. And I'm going to say, hey, I'm going to leave a note for someone in the future. I made the webbing thicker, on this part right here, and I'll check it in. It's now transferring those changes back to the server. It's created version 3 of 3. You can still check it out and make more edits, but now anyone could come in here and say, hey, let's look at the history of this file. I can see when it was created and the notes left with that, and I can see it was checked in just now by Philip, and he wrote made webbing thicker. Okay, that's pretty interesting. In fact, I could roll back the clock and look at any of this stuff. I could say, you know what, take me back to version 1. Go get version 1 from the vault. Let me see what that looks like. And I can see the webbing was thicker, and actually on this type of part, there was an angle over here that was much smaller. It didn't have enough clearance to fully open and close those jaws. And if I'm looking down my PDM task, I get notifications that tell me, hey, the file I'm looking at is older than the latest one. You might not want to work with, some old files from way back. But I can just go, hey, go grab from the server, go grab from the vault version 2. Let's see what that looks like. And I can see here the clearance has been opened up. They got about a 120-degree angle now inside of that opening. But of course, I'm just going to hit the latest version, say grab that one from the vault, because, hey, it's most common to work with the latest version of any file, and that's what I want to be dealing with. All right, so I've checked something out. I've made a change to it. I've checked it back in. You now know how to use SolidWorks PDM. That's the end user learning that needs to happen for a SolidWorks user. I used the where used functionality there, and I noticed, hey, this is used in an assembly and a drawing, so that's what my changes are going to affect. So let's close this. I'm going to go back over to the assembly, and I can see, okay, yeah, I would have made a change here. So I'm going to go ahead and check this out too and make some more changes on it. So here, this time I'm doing it on a right click. I'm just opening up my task pane, and I can see all sorts of information. The assembly is in a state that I can edit it, so I'm going to check it out. And because I saw that drawing, I'm just going to use the dialog to go ahead and check out the drawing at the same time, because I'm going to end up needing to edit that too. And I'll just hit checkout. Now I can see just this top level assembly is checked out by me. Other people could be working on these files. Many of these files are actually approved. And in that case, you wouldn't be allowed to edit them because they're already released for manufacturing. You'd need like a Rev B. And I can see one here has had a change on it. I could review that. But let's make some more changes to the top level assembly. All right, one of them is, how about this pin in here? I know there's a couple pins. I'm going to choose a different pin, maybe something that's made out of steel. So I'm just going to delete these out of here. Now, I mentioned that this is all built on a PDM database, so searching is much better than Windows. So I'm going to use the PDM Search right here and just search up a new pin. This is what it looks like if you're using the CAD editor. I'm going to maximize it so it goes full screen. And I'm just going to look for anything with, I'll just go by description, type in pin, and bam, instantly, no matter how big my database is, it just comes back. All these things had pin in the description. And you can dig really deep on pieces of data like this. For instance, let me show you data cards, because this is just kind of searching descriptions of files, by name and location. They're in my vault. But I'm going to go to cards. Now, for every file extension, every piece of data, we might have a data card which stores the useful information that we want to know about that type of file. For instance, I'm going to go down to SolidWorks parts, SLD PRTs, and this is what the data card looks like. This is also customized for me. And on a SolidWorks part, I always want to be able to see really quickly part number, description. Here's one for material. So I'm just going to add 4340 in for material. And then it parsed it down and said, oh, with pin and description and made out of 4340, which is just a part of actual material named steel, we found this one hardened tipped pin. When I click on that pin down at the bottom, I can see more information like where used information, the data card of that pin, what it's made out of, who it was created by. I've even got a preview window here, which just has e-drawings built in, right? The free viewer e-drawings. So I can roll it around, I can measure it, I can make sure, yeah, this pin seems like it's going to work. And because we're using SolidWorks, I'm just going to drag and drop this guy into the design. That's always a nice way to use SmartMates too, is drag and drop from one window to another. Could be Windows Explorer, could be SolidWorks, whatever. So I searched it up very quickly and found the pin I needed. Now I do know in this file that there is a mirror component inside of here, and I want this pin to be included in that. So I've got a pin on either side of this thing, and it's looking pretty good. It's looking good to go. That's really all I wanted to change here. I search something up, swap it out, but I know from the where used info that there's a drawing of this that I need to change as well. And I could open the drawing just right-clicking in the tree. I could grab it from the PDM task pane, but I'm going to use File Open here because I want to point out to you guys that this is built in to Windows Explorer across the board. So even when I hit File Open, all I'm doing is I'm looking on my C drive, and I have a vault here, and it looks just like a folder. And when I open it up, here's my vault. It's got a folder structure inside of it. Here's my assembly. So I can see the data cards of it, what version it's in, who has it checked out right now, which is me. And I'm just going to grab the drawing and open that up. There's very little new things to the interface here. There's a nice task pane pullout for a SolidWorks user to get all the info that you could want inside of SolidWorks. And there's the need to know that you need to check in and check out, maybe hit where used, but pretty easy to use if you use SolidWorks. And I can see here, okay, I did break a reference because I swapped out that pin. So I'm just going to reattach this balloon so it gets a nice item number. Honestly, I should have changed an exploded view and exploded those things out, but I didn't. Yeah, that's okay. I'll leave it like this for today. I can see a part number you're on a retaining ring needs some help. Let's just say that's good for our changes right now. And I'm going to take this drawing and just check it in. I'm going to say I'm done. Let's release this file so that other people, could work on it as well, and I don't have it just reserved and checked out to me. And notice it's also checking in the assembly that I had checked out at the same time. So that's kind of convenient. I'll leave that checked on, and I'll say I swapped out a pin for steel. Right, so I got a history. Of course, it's going to know what user did it and what time of day and all that stuff, but I like to put a nice traceable history there that people could look at. So I saw a few things that changed less, but let's say I'm pretty happy with this drawing. I'm good with this drawing. I'm good with this assembly. I want to release it to manufacturing. I want PDFs to go out to the right folders. I want managers to approve it, all that good stuff. I could do that here in the task pane. You've seen me work here a bit. I'm going to show you how to do this kind of stuff just from Windows Explorer, really. So I'm just going to close these down and pop up a regular File Explorer. Here, I'll maximize it. It's just my computer. Now my C drive is where I've got my folder for my vault. And inside of there, I got a project folder for this spreader arm, and I can see, my assembly and my drawing inside of here. I've made some other work ahead of time here as well. I actually made a new part, a new rod end. I made a drawing of that rod end. Here you can kind of see what this rod end looks like that connects things together. And along the ways too, we changed the range of motion that those could open up by increasing an angle. So really, I'm going to take all of these components here and just right-click them and say, hey, submit them for approval. I want some people to stamp these Rev A if they're new, Rev B if they're moving around, and I can leave them a comment to see here and say, please approve this work. I never make mistakes. Don't even check. And when I say okay, I'm now kicking this off to be approved by a manager. I almost forgot about this. I actually have an automatic task set up for myself. Whenever I submit a drawing through the workflow, I have the design checker set to run. If you don't use the SolidWorks design checker, you ought to look at it. You can learn from a current drawing all the things about that drawing in terms of like arrowhead size and font and all the things that should be a standard. And so I can just run over it and make sure, okay, I didn't use Comic Sans somewhere on this drawing. But I'm not going to run that. I'm going to hit cancel and just let it move forward. So now all of my different files are sitting in the waiting for approval workflow state. I mentioned workflows earlier, so let me show you the simple workflow that I'm working with. It's pretty simple. Those files you saw me checking out and checking in, they're sitting in a state of this workflow called under editing. A lot of people call them WIP, work in production, I think. Under editing is what I've got, and I've got different groups of people that could do different things. So an engineer with a file in under editing can do just about anything to that file, right? Same with managers, definitely admins, but maybe somebody from the documentation group can only come and read the file contents. Now, as I submit that for approval, this little bell tells me a manager or whoever's in that approvals group is going to be automatically notified. And then when it's sitting and waiting for approval as an engineer, I could pull it back and say, oh, I didn't mean to do that yet. But that's about it. I need a manager to go pass approval, and I'll get an automatic notification on that. And then it can sit in the approved state. You know, engineers can't do too much with the file once they're approved. Perhaps another task runs to put PDFs in the right folders at that time until some manager comes around and says, hey, we need a change. And then we can go change pending, put this in under change, basically bump the rev to rev B. So as you can imagine, there's a lot of workflows you could have here. You can have them for different file types. You can have different parallel and serial workflow structures, but this is the simple one I'm working with. So I'm going to put on a different hat here. I'm going to log out. Let's do this for my task train. I'm going to log out of PDM. And then I'm going to log back in as a manager. You can do this in the task pane, or if you just click the folder in Windows Explorer, but I'm going to log back in as my manager. So just kind of changing job duties right now. And as a manager, you have a couple of choices. That waiting for approval, it could have sent him an email, just his Outlook account. Or there's actually an inbox inside of PDM. We could have sent a notification over here. So as soon as he starts up his computer and logs in, he can see anything that's waiting on action for him. Same with a simulation user, right? If they've made a design change, maybe my simulation user needs to be notified, time to run a new sim, or somebody in technical documentation needs to update the images. Just hit update in Composer and bam, tech docs are up to date. But I'm going to stick with my manager's hat. I'm going to get back into my vault. I didn't set up a notification in my inbox. Instead, I'm going to go back to that search tool. I mentioned the search tool from inside of SolidWorks. It's here in Windows Explorer as well. Looks pretty similar. And this time, instead of searching for files by name or by, cards or custom properties, or who's got it checked out right now, or is it Rev A or history, there's so much you could customize and search for. I'm going to search through the workflow. And I'm going to say, hey, just show me files that are currently waiting for approval. That's it. That's my job. And I can see, oh, okay, there's a number of files here that are waiting for approval. And I could check these out. Like, let's check out my drawing. You see the data card of it. It was created by by Philip, my engineer, on today's date. And if I go look at the preview of these as well, I don't need to open these up inside of SolidWorks to have a look and see how they were made, what they look like. So you can't ever blame your managers anymore for moving something around, or somebody going, hey, well, I just rebuilt it and changed. It's like, no, that's okay. They don't even need to open the actual file up. They can preview it here. And I'm going to say, as a manager, I know Philip. He really doesn't make mistakes. He's amazing. So I'm just going to go ahead and say change state. As a manager, I can say this stuff all passes approval. Except maybe I won't pass that SMG, that Composer file. Technical docs, need an update on their images, I'm sure. So I'm going to say, good work, Philip. You are my #1 employee. I'm sure a Christmas bonus is coming this year. I'm going to hit OK. And now all these are transitioning into the approved work state. I can actually see it already here, except for my spreader SMG document that I chose not to approve. So let's take another look at that drawing that I just approved. Make it a little bit larger inside of here. One thing I want to point out for you, while my notes need a little bit of adjustment on my template, I'm logged in as Brian on today's date, and I just approved this thing. It got stamped with my name, and it got stamped with Rev A. So not only does my manager not need to open my file up and possibly move around something, they can actually approve this, get dates, get custom property mapping to it just from PDM. It's called attributes at this point, basically. You can type them into the data card just like you'd put a custom property into a file, or you can do stuff like this and just approve something and bam, it's Rev A. As a manager, I don't need to even have SolidWorks installed to do any of those actions right there. Boy, I think I just went pretty far through a workflow. I just edited parts, checked them out, changed them, edited an assembly and its drawing. I submitted all that stuff for approval. I took a look as the engineering manager and reviewed. I could even review the history. One last thing I may have wanted to do as a manager, or I don't know, just as a purchasing person, is when I'm looking at an assembly like this that's changed, is check out bill of materials info. Right, I looked at where used info and contains info, so I could see, when I affect a part, does it go other places, bill of materials are hand in hand, right? So I can see, okay, this is the current bill of materials here. I could export this to CSV. You can make bill of materials that are named and are just here, so we could add parts to it that engineering didn't think about, like, I don't know, some paint or tape or something like that. And I could compare a bill of materials. Let's compare this against the initially created one. This is what my comparison looks like. So you can see the hardened tipped pin that I added. I found it in our libraries of approved parts. I plugged it into my assembly, and I've got little green spots next to all the new information, which is completely new. We've added another component here, as well as the arm got changed, and I can see its revision has changed, the quantity has changed there, as well as a few other components that changed in design. And the old pin down here with the red flags next to it showing me that it's been removed. I really like the bill of materials comparison. I don't know where else you would do that outside of using SolidWorks PDM. So pretty powerful functionality there. So that was a quick live look at SolidWorks PDM. I hope that gives you an idea of the type of functionality that can be done here, because these are very customizable. And that's really what MLC is here to help for as well. So brief summary of what you guys just saw. PDM is a data management vaulting system that the goal of it is to help increase engineering throughput, right? To maintain that everyone is getting the right data at the right time, and as you would just assume your computer should work, right? None of this final, complete type of files, and everyone knows where things are in the workflow, and whose job it is to make a change at that point. It's obviously tightly integrated into SolidWorks, as well as a few other Microsoft Office and a few other programs, or just Windows Explorer. And it's synchronized with the releases of SolidWorks. We're here to help you guys set this stuff up, customize it to your environment, get it installed, migrate over from other systems. That's what MLC is here to help for. In fact, we can even host the entire solution for you. If you don't want to deal with setting up a server, hiring some third-party IT, installing SQL, while we'll help you guys with all that stuff in implementation, we can also take on that entire project and just do a hosted server solution for you. So that's a nice, easy way to get the job accomplished as well. I do want to point out the licensing. I talked about it a little bit earlier. SolidWorks PDM Standard is included with every seat of SolidWorks Pro or Premium. PDM Professional is the largest one. And for either one of these, you'll hear the licenses talked about with 3 different names. What I generally use is the CAD editor license. That's the one that runs inside of SolidWorks. It's the one we all here are probably going to use every day. Then there's a lighter, cheaper contributor license. Doesn't have the SolidWorks add-in, but it has the Microsoft Office integration. It's great for project managers, great for purchasing groups. All you really need to do is maybe put in Excel sheets, grab some bill of materials, save Word documents into the Vault folder. Because remember, this can manage any file type. Just put it in that folder and check it in, and it's managed. The lightest weight one is a viewer. I think these are awesome for the shop floor. You can view in Windows Explorer. You can use the free viewer that's in there based on e-drawings. And perhaps, when something goes to Rev A, those PDFs automatically go into a folder that's going to be hitting the shop floor. Those people have a computer out there that they're, using SolidWorks CAM on or doing some CNC programming with Mastercam, and they just want to view these PDFs. You can make sure the right people are seeing the latest PDFs and the latest data here, and there's no question. So that's a brief overview here of SolidWorks PDM Professional and PDM Standard. I'm going to take a quick look at the questions, but I don't see too many questions on here yet, which is good. Don't forget you can type them in, and I'll try to answer them in spots like this. I've also got coworkers watching that, so you can get a pretty immediate answer on this type of stuff. But I'm going to assume without questions in here right now that I'm not looking at the wrong things, and that I've done a really good job of explaining this stuff at the moment. And so I might circle back around to this towards the end, but I'd like to keep moving forward then into the simulation portion of this, being mindful on our time. Because I've mentioned how all of these products work together, right? You might have a simulation user, as soon as you make a design change, they need one of those automatic notifications to know, hey, we need to ensure this is going to meet our minimum factors of safety. It's not going to have too much stress, or maybe just involve them in the design portion. They could run a topology study and help reduce weight, or just make that a part of the approval process. So these things are all linked together. And I'll talk a little bit about managing simulation data, if I remember as well, what to do with those result files. Remember, all of the setups for simulations are stored inside the SolidWorks files that are data managed. So I'm going to do this just in two big bulk things here. I'm not going to go as in depth as I went with PDM, but I want to talk a bit about all of the different simulation offerings that you can get your hands on today, because it is a broad landscape of things you can do. Generally, we think about simulation and the name SolidWorks Simulation as, is it strong enough? What are the stresses and displacements of factor of safety? But you can do a lot more nowadays with SolidWorks Simulation offerings, so we'll look at some of those. And then a quick live look at SolidWorks Simulation. I'll show you an actual issue that the company Homatro had with that same rescue spreader, that they made a design change really to figure out if they could go with a cheaper manufacturing method. But by doing that, we need to ensure too that it's going to be strong enough for its application. So let's talk about a bit about the landscape, starting with what is just called SolidWorks Simulation. Just that name is the brand of this product. And this is finite element analysis. We're going to break these things down into little triangles and elements and do the math in each one of those little elements and find out, is it strong enough? Is it strong enough is a linear static analysis for parts and assemblies. It's the one everybody pretty much starts with, no matter what higher level you're getting into. And that's actually included with SolidWorks Premium. So if you have a SolidWorks Premium license, well, you can actually run linear static FEA for parts and assemblies. Now, above that, simulation has a three-tiered licensing structure, just like SolidWorks does. So we got standard, professional, and premium. So if you find a nice bundle, if you talk to Nathan and he's like, hey, actually right now, if you buy SolidWorks Premium, it comes better with Sim Pro, sometimes you'll end up in one of these three packages for pricing regions or just for functionality. Maybe you want linear static, but you also need motion analysis and fatigue studies. That's the Sim Standard package. Now, most people do fall into Simulation Professional. It covers everything in Simulation Standard, plus all these other study types. Frequency analysis. Are we going to have a harmonic response that could potentially be dangerous? Anything you're bolting to an engine, you got to check that out. Thermal analysis. Optimization, how thin can we make this part? Or topology studies. Tell me, SolidWorks, where I could possibly remove material and make it more organic shape. So just a huge number of studies that are all pretty easy to run, and just turn your linear static analysis into one of those analysis types. Then at the high end, you've got Simulation Premium. A little more niche, this is where you're running a non-linear study. Maybe you're dealing with gasket materials or something that just has some type of non-linear nature to it that you couldn't do in a linear static analysis. Same with dynamics. You're going to do a seismic thing, or you actually have a shaker table, or you want to input that frequency. That's where you get into dynamics. And really what I see used quite often in Sim Premium is composites. Composites could be done in a linear static analysis. It doesn't have to be a nonlinear dynamic. Composites is just the ability to do that laminate stack up of fiberglass, of carbon fiber, of those things with different grain directions. So if you want to add that capability, that's in Simulation Premium. There's also where you could run a dynamic fatigue study as well. Now that's all your FEA stuff, and of course it's all run inside of SolidWorks, same interface. So is Flow Simulation. We call this SolidWorks Flow Simulation. That's the name of the tool set. This is CFD, or Computational Fluid Dynamics. This to me is one of my favorite sim packages I get to mess with. It is just awesome. It does so much stuff, and it gives you really amazing qualitative outputs as well as the hard numbers to things that I think are generally counterintuitive and have crazy effects. Virtual bodies that are affecting drag calculations, the Coanda effect, things at high Mach number that, in stress, I can usually predict where the highest stress is. In flow, a lot of strange behaviors can happen that this tool is really for. There are two extensions to it. So there's just one license, Flow Simulation. There's an extension for electronics cooling, should you want to do stuff like run current through a resistor and find out if you're going to burn a fuse up. And to extend databases and have better PCBs and heat pipes and thermal resistors built in, thermoelectric coolers. Now, there's also an extension for HVAC. I want to point out it's not just for HVAC companies who want comfort parameters. It's actually advanced radiation that takes into account the spectrum of light. So you can imagine, Philips light bulbs, anybody running LEDs, grow light operations, anything in outer space, satellite dish stuff. You might be looking into a more advanced radiation study type. And those are just two add-on modules to the SolidWorks Flow simulation license. Now, one that not everybody gets into is actually called SolidWorks Plastics. Again, just in the same interface, this simulates the injection mold flow process. So are we going to have manufacturing defects, or could we just design our part better? Can we do thinner walls? Should we increase draft? Should we specify ABS, plastic, or polycarbonate? That's really all in the plastic standard package. So again, 3-tiered packaging. Then you could say, yeah, I'm a designer. I'm going to use some plastic parts. I don't want them to have weld lines where fluid flows came back together, or de-linked surface effects where I've got text. You could check all that stuff out with plastic standard. Now, if you're getting a little more complicated and you're doing overmolding, you want to run multiple cavities inside the same mold, maybe you own an injection mold machine, you're definitely going to want Plastics Professional. And at the highest level, if you're designing the molds themselves, the cooling channels inside those molds, plus you want to calculate the warping that would come out after the mold is opened up. So we're talking after the pack cycle, after the full cycling is done, and find out if you're going to have some warping. That's at the highest level here, the premium package. So anyone doing plastic parts, I think this makes a lot of sense in the design. I think there's a lot of miscommunications I see out there with plastic parts, not always the same high level of communication I get from a machine shop, but there's no reason why we couldn't just design parts that we know are going to work well and cheap as soon as we send them out to be injection molded. Yeah, plus molds are expensive, right? Get it right the first time is pretty handy there. Now, there's one high level. I'm going to bring up 3D Experience again. It's brand new. I mentioned there was some plug and play cloud data management solutions there. There's some really high-end simulation stuff there that's built upon Abacus. So I just talked about SolidWorks Simulation, FEA, is it strong enough type analysis. And if you think about it, they're really easy to use for anyone in SolidWorks, right? Designers, engineers, maybe somebody who isn't a data analyst and that's all they do and went to college for. The SolidWorks tools are for us. We can all just get our hands on them and go. If you are running Simulation Premium in the nonlinear world, you might run into some troubles because nonlinears can sometimes be divergent. Material properties are really important. And you might want some additional capabilities, like to be able to do brick meshing. Well, 3D Experience from Dassault Systems actually allows this at a level up called Structural Performance Engineer. This is built upon Abacus, the solvers and meshers of Abacus or Simulia, and it is in their cloud platform. And this extends the capabilities of what you could do with nonlinear studies. In fact, every study that runs there is nonlinear. Every contact condition by default is no penetration, and it is a very high-end simulation tool. They even have one above that called Structural Mechanics Engineer that does everything Structural Performance Engineer does, plus it adds in dynamics. You can really do some wild stuff here. Take a look at our YouTube channel in the next week or two. We're going to have a new webinar up that shows some usage of this software. And if you're into that really high-level FEA stuff, I think this is going to be something interesting to you. But I want to stick with SolidWorks Simulation. Really, it's for any designer, any engineer to use. It's fully integrated into the SolidWorks interface, just like the SolidWorks Flow and SolidWorks Plastic is. So you can make use of configurations. You can use all of your workflows and data management real nice. Now, I should point out, Simulation Express is in every seat of SolidWorks. So if you open up SolidWorks and you go to the Evaluate tab on your Command Manager, there is a Sim Express wizard. It works just for parts. There's some limitations of just doing force, but it's a great tool to start off with. It will ask you for a product code. Just follow the web link that's there. That product code is free. All right, linear static now for parts and assemblies I mentioned, that's included with every seat of SolidWorks Premium. So if you have SolidWorks Premium, fire it up. You don't need Sim Express. You can get right into it. And these are tools that if you use SolidWorks and you know how to right click, you're going to be able to use this stuff. So let's take a look then at some SolidWorks simulation. Now I want to show you the handle of that same spreader and do a little simulation work there. It used to be designed a little bit differently. So I'm going to open up, I might open up that same assembly again. Here's an assembly of just the handle. You can take a look at that. And you know what? I don't even need to check this out. You can see when I'm opening a file, PDM is saying, hey, do you want to check it out and take control of it? Let's just do some what if work. So I hit cancel there. I didn't check it out. I'm just looking at it, just seeing what I think. Now, this handle used to be a welded form. It used to just be made with a sweep, but sorry, it used to be a bent, just made with a form. Now it's a welded design where we have a flat panel that's getting welded onto some tubing. It's much cheaper to manufacture for us that way, but I want to find out if it's strong enough, right? So I'm just going to start with just the part and open this guy up. Again, I'm not even going to worry about PDM's prompt there to check it out. I'm just going to do this as read-only, as kind of a what-if study because, well, this is already released. It's already approved. And I'm going to fire up Simulation. Now, Simulation is just one of your add-ins. You go Tools and Add-ins, and you can check on SolidWorks Simulation. Once you do, you'll get a Simulation tab at the top, and you get a Simulation drop-down menu. I'm going to talk a little more about data management because under this Simulation drop-down menu, there are options that are just for simulation users. You need to have the add-in turned on and a file open to see these options, which I do. So I'm going to hit Options, and this shows me all my default options for new simulations. And I want you to notice there's a results area. What I personally like to do is make a folder on my local machine where all of my simulation results go, and I don't worry about checking them in or out of PDM. It's totally up to you. There's options in PDM to go either way, but I like doing it this way. My simulation setup is saved in this part, and that'll be checked into PDM. And if I ever want to archive results, I just put them in a zip folder. I just go to this folder and zip them up, or I do a pack and go and check the include simulation results box. This is also nice because simulation results can take up size. They can take up some space. And, you know, I like to get in there every now and then and just delete all my results. I can always get them back by just hitting run. I'll get the exact same thing. So, you know, I just go in there and delete results sometimes. All right, that's really all the data management I do. Otherwise, I'm just going to start up a new study. And notice when I do that, I've got all the study types of all the licenses. Static is what you get with SolidWorks Premium. If you have Simulation Professional, you'll see everything here except for nonlinear and linear dynamics. So SimPro gets you most things, including topology studies. But whatever you do, just start off with a static study. So I'm going to hit the green check and start one up. I know I didn't check it out. PDM's like, are you sure? Are you sure? You're modifying this file. I'm like, yeah, I'm sure. I'm going to lose all my work at the end of this. And I'm going to open this file up, and I can see SolidWorks knows how to deal with it a bit already. It knows what mesh elements to use, and it knows what material is on it. Some more of that 4340. I like it when you're in a study, if you check material, it's the same material database that you'd use inside of SolidWorks. But when you do it in a sim study, it color codes in red the material properties that you have to have for that study type. So easy way to know if you're making yourself a custom material, what materials you absolutely need to go find and use in the study type. Now, there's also a simulation advisor that will hold your hand and walk you through this thing like a tutorial. I'm not going to use that. I'm just using the sim tree, and I'm moving from top to bottom. Now, I know these symbols. I know this is going to be high quality tetrahedral solid elements using this material. Just the symbols in the tree tell me that. I'm on a single part, so I don't really have connections, but I do have some fixtures to the rest of the world. And to keep things really simple, I'm going to use fixed geometry on the holes that I'm going to bolt down. Now here I'm just using the G key to open up a magnifying glass. I know some of you guys like that. I'm going to hit the G key so I can click on these internal faces. And that's the simplest way. I could put in a bolt connector and look for tear out and stuff, but I actually know that it's not a big deal there. My bolts are fine. So I'm just going to say those holes there are infinitely rigid. Kind of a big engineering assumption. And then I'm going to add an external force onto this thing. Somebody could be holding on to this face right here and pulling. So I'm going to select a plane to measure the direction that they might pull against. And I'm going to say, okay, I'm going to allow somebody to pull, let's say, with 500 newtons in the direction that you see these purple arrows going. All right, they're going to be held down by those bolts, but somebody might really be yanking on this thing, and I don't want it to fail. Now, I could spend all day talking about meshing and solve time and accuracy, and I actually do in our training courses, but I'm just going to hit run because that's all you need if you're running a SolidWorks sim. You got a shape, you got a material, you got a fixture and a load. There's a lot of options for those things, but you just work from the top of the tree down and put those things in, and bang, you got a simulation that ran. What I like to do first, I'm looking at a displacement plot, and it's exaggerated is really only 0.18 inches of displacement, but it's exaggerated so that I can animate it on my screen and sanity check myself and go, is this the directions this thing would bend if I'm moving it? Because my fixtures and loadings have to match the real world, right? That's the garbage in, garbage out situation. So I'm going to assume, looking at this, that I gave it good fixtures and loads, and my assumptions were okay. So then I might find out, where do I have the max stresses? And I have them down in the bottom, not too bad around where I'm going to end up welding this thing and actually increase strength, but near those bolts, and that's not amazing. I can tell it's not failing though. My yield strength of material is shown here, and I'm not above what the material can handle. And another great way to see that is a factor of safety plot. So I'm just going to create a new plot. You know, it created a few plots for me automatically, but I can make all sorts of plots. I'm just going to make a quick factor of safety plot that's going to compare the von Mises stress, kind of a worse stress here that it shows automatically because this is metal, against the yield strength, or what the material can handle. And I'm just plotting this from a minimum value to a max of like 2. So my minimum factor of safety here is 1.5. I can see where it is. This can take about 1.5 times the loading before it starts to permanently deform and be bent or even destroyed. So it passes, it's successful, but 1.5 is not a lot. And this isn't just consumer product, this is life-saving product. So let's see if we can get that higher. I would like the factor of safety to be above 2, so I know I could safely, you know, double my loading conditions and not have to worry about replacing a component on here. So to do that, I'm gonna actually fire up a design study. And you could do what I'm doing here for the most part, even in SimExpress. But if you want to get heavy into topology optimization or just design study, which I call parametric optimization, you're probably going to need SimPro, Simulation Professional License. But this is what a design study looks like. And as simple as I can make it, it lets me pick things to vary. So I'm going to add a variable here. And an easy way to do that is just find a dimension on my part. Let's say this 6 right here. When I click on that, it becomes linked. And I can give it a name like thickness. Give me the thickness of the part. And I'm going to say, hey, that thickness right now is 6. I know I want to make it thicker. So I'm going to say the minimum value you can choose is 6. The maximum value, I'll leave at 9. And it's going to range by 3 millimeter steps. Since I've got SimPro, I'm just going to say, hey, just range. I don't know the step size or discrete values, but I cut this myself, so you can pick any thickness you want. Now, I need to give it a limit or a constraint. And the easiest way to do that is add a sensor. Sensors can be used for anything in SolidWorks. They're like the oil light in your car. So you can just say, hey, give me an alert when my mass gets too heavy in this part. But I'm going to set a sensor that watches simulation data, and I want to watch that factor of safety, right? The minimum factor of safety. So I pop that sensor in and say, my factor of safety has to be more than 2 in that static study I just made. That's my minimum. And a goal, the most common thing, honestly, is add a sensor for mass, because my goal is to be as light as possible. I want to add material, but as little as necessary to get my factor of safety above 2. And with the optimization checkbox checked, I can just hit run. Now, I only gave it one variable. If you just give it one thing to vary, it's going to come up with 5 scenarios or 5 individual simulations to run, and it's just starting to crank through them right now. It's going to choose my smallest size. I'm going to jump up to my largest size, and then it's going to compare that to my goal and essentially split the difference. And we can put as many of these in here as we want. You could vary temperature loads and frequencies and all the different study type results. Or you could even run a topology optimization where we don't specify where we're adding or removing material. We actually let SolidWorks just guess. And that's a cool study type also in SimPro that generally comes out with ergonomic and very natural looking geometries, look kind of like nature. But this is a very prismatic part, and I know a dimension I can change. And it tells me, hey, an optimal value of that dimension would be 7.5 millimeters. So I'm just going to leave it selected 7.5 millimeters, and then I can, basically already have that 7.5 in my model, as you can see, and I can jump over to my static study and interrogate those results deeper if I'd like to. In fact, I always like looking at stress results with the mesh at the same time. I know I didn't talk too much about the mesh. All I said was come to my training class to know if this is a good mesh. Hint, it is not. It needs more work. But I think what's cool to look at for these is a design insight plot or an ISO clipping plot, where you can actually move a slider and look at where the stress values are highest. So here's kind of materials that are doing the most work to where there's lowest. A lot of times in very prismatic or square type parts, you will find areas that, like here where I've got holes, that are basically not contributing at all to this loading condition. And you can think about new places you might remove material in a way that you even control with dimensions to get a lighter, more efficient part, which still meets your goal of getting over that factor safety of 2. So that was a real quick look at the basic SOLIDWORKS simulation, the static analysis type of FEA that's included with SOLIDWORKS Premium that uses some of the optimization techniques of Simulation Professional. The point I want to make is that this stuff is for everyone using SOLIDWORKS. Use it in the design process. Yes, you can use it to figure out why you had a failure in the field and reverse engineer, but use it early in the design. When you make a change, let PDM notify whoever's your sim guy on the team that he should verify it for form and function and include his approval with it. Now, I mentioned training because it is an FEA tool, and it's very important to get this stuff right. So we have a training course that I teach. Teaching a lot of them online nowadays, as you can imagine. We do them as a public class or a custom class. And in 3 days, you can learn everything you need to know for setting up parts to complicated assemblies and to really knowing, do I have a good mesh? Have I picked the right elements? Are my contacts in between parts accurate? Can I trust these results in their solved solution? And do I have an efficient solve time? That's the goal I'm trying to get across. There's a lot of tools to use in here, but I think that's the most important stuff. We do all of that in 3 days. If you want to go above that, if you bought Simulation Professional, just 2 more days on that. So some days sometimes we do a 5-day long course because once you've learned those fundamentals of meshing, of contacts, of fixtures and loads, those fundamentals stay the same as you get into these other study types. So we can make those analogous to thermal, to fatigue, and it's really just knowing about the machinery at that point. So we cover all of this stuff in just 2 more days of training. We, of course, have training classes as well for flow simulations, for plastics, and for higher level sim, but these are the ones that I think just about everybody with SOLIDWORKS gets into and can use. And if you're interested in knowing more about what's covered in those training courses, or just to see these other sim tools in action, check out our YouTube channel. We've got like preview of our public training offers there, and we've got different custom stuff that I've put together for flow and for sim that I thought just had amazing output. So we have the YouTube name MLC CAD Systems. Not too hard to remember. Check us out. Please subscribe to my YouTube channel. You can reach me directly after this as well, philip.morrow@mlc-cad.com,